If you've ever wondered what grep actually stands for, it actually stands for Global Regular Expression Parser. So I think it's fair to assume that grep makes strong use of what we call regular expressions. Now, interestingly, grep is not the only program that uses regular expressions. It's actually used quite extensively by other Unix programs, and I'll show you which at the end of this module. So understanding and using regular expressions is an important part of the arsenal of any shell programmer. As a shell programmer, you're really handicapping yourself if you don't understand what a regular expression is or how to use one. So let me show you now regular expressions by using grep as our example. So, what is a regular expression? It is a term used to describe a set of special text matching patterns. So the best way to explain that, I guess, is to show you some examples of those. The text matching pattern caret, or the little up hat symbol, matches the beginning of any line. So caret ABC matches any line of text that begins with ABC. So let's have a look at that in action using grep. I have a text file called sample in the current directory, and I'm going to search in that file. I'm going to search that file called sample for lines that begin with ABC. Now let's see if there are any. So we'll search for grep, and then notice that I'm going to put a single quote around this, caret ABC, and then single quote. So I've enclosed caret ABC inside single quotes, and then the file called sample. So what I'm actually doing is I'm searching in the file called sample for the pattern caret ABC, which really means ABC at the beginning of a line. So I'm looking for lines in sample that begin with ABC. And let's see if there are any. And there are, in fact, 1, 2, 3, 4, 5. Now that's not all the lines in the file. I'll prove that because I'll do an ls-l of sample, and it is a really large file. It's nearly a megabyte. In fact, it is a copy of the /etc password file from this computer. So if you like, 1, 2, 3, 4, 5 users on this system have their names that begin with ABC. I could just do a search for ones that have ABC anywhere in their name, like this, and I get a few more, 1, 2, 3, 4, 5, 6, 7, 8, 9, roughly 9 or 10. But by putting the caret symbol at the beginning of the ABC, I restrict the search to the ABCs that are at the beginning of the line, which of course enables me to perform more powerful text searching, which is in actual fact what regular expressions are for sophisticated pattern matching. So let's have a look at some more of the regular expression pattern matching facilities at our disposal. ABC $ matches any line of text that ends with ABC. So let's see if there are any of those, and I'll do a little search for them, and there's absolutely none at all. And now what that actually means is that the line does not end in ABC. Typical lines actually from the /etc password file end in the name of the shell that you're using, so we don't have any shells called ABC. So what about if we had a shell called just simply sh? How many people are using just sh as their shell? And there are 6 of them. I put the slash in because I didn't actually want the shell bash to match that. Okay, so that's the end of the file, which is kind of the opposite of the beginning of the file. So let's have a look at some more. We can obviously combine those two together, and if something begins and ends and there's nothing in between the beginning and the end, then we've obviously matched a blank line. So moving right along, a asterisk matches any sequence of 0 or more A's. I'll show you an example of where you might use that. So if I was to search for CA asterisk T, what I'm actually searching for is either CAT or CAAAT or CAAAAAT, or even a C and a T with no A's in between them whatsoever, because recall that it matches 0 or more of the character immediately preceding it. So what we're actually asking for is a C followed by 0 or more A's followed by a T. So let's see if we find any. Well, there was certainly a bunch. Now I'm just looking at the output here and I can't really see any instances of more than one A, but I can see that there are some instances where it's CAT and there's other instances where it's just CT by itself, like the third one from the top, tectonic. That doesn't have any A's in it whatsoever. It's just a C and a T with 0 A's in between. Now if you actually want to match at least one A, for example, then instead of using the asterisk sign you use a plus. But the plus is actually not part of the standard regular expressions. It's part of what we call extended regular expressions. And so if you want to use extended regular expressions, you have to use a special option to grep, the -E option. So I'll show you that now. So here's the same example again, only with an asterisk replaced by a plus. And we run that and we get absolutely no results at all. And yet we were expecting some results. We were expecting to see maybe all the CATs. And the reason we didn't see any is because we actually need to specify that this is going to be a regular, an extended regular expression. So what we need to do is put in just here a -E option, E for extended regular expressions. Now I've actually made a little mistake here. It's actually not lowercase e, it's actually uppercase E, so I'll just quickly fix that. I'll put in the uppercase E for extended regular expressions, and this time we in fact match quite a lot. It is a little bit fiddly to know which parts of the regular expressions are extended and which ones are not part of the extended set, but that's, I guess, just part of the joy of Unix. Moving right along, we can use the square brackets in a very similar way that the shell uses square brackets to match file names. Anything enclosed in the square brackets is used to match a single character. So C followed by square brackets followed by T matches C and then any single character from within the square brackets and the T. So C square brackets AOU brackets T matches cat, cot or cut, but nothing else. It will not match CAOT or COUT because it's only trying to match one character. So let's look at an example of that. Now we already know that there are many CATs, but how many OTs or CUTs are there? Well, there's still a bunch, and if you verify for yourself on every single line there's either a CUT or a COT. It is of course possible to combine that and with one of our earlier options and put an asterisk there. Now what that will give us will be a C followed by 0 or more O's or U's followed by a T. So that will of course match the option CT, but will also match COUT or COOUOUT or any combination of O's and U's between the T. So let's just check that, and I guess we'll have to assume that's working. I can't actually see any O's and U's next to each other between the C's and the T's, but I assure you that is what that option does. Now one of the more important regular expression options is just the dot, which matches any single character. So C dot T matches a C followed by any character at all followed by a T. So it could match an A or an O or a U, or it could match a space, or it could match a for, or it could match a question mark, or it could match absolutely anything at all. And that is often used in the following way. You would put a dot star there, which means a C followed by anything at all, and any number of those anythings at all, even 0, followed by a T, which of course translates to a C and a T with anything in between them, even nothing. So if there is a C on the line and a T on the same line somewhere after it, then that will match. So we'll just run that, and there's a great deal of them. And if you maybe pause and have a look at the output that you've got, you'll find there is a C and a T with any number of characters in between them on every single line that you can see. Now just getting back to the square brackets for a moment, you can actually use a range of characters inside the square brackets, and the range is specified by the first character followed by a dash followed by the second character. So we've got A to Z and then capital A to capital Z and then 0 to 9. So the example you can see in front of you matches 0 or more of any of those characters, so 0 or more letters or digits in between a pair of capital X's. Now that's just a small subset of the regular expressions that are available to you, but that's probably the most common set. If you want to learn more about regular expressions, then look in the man page for grep or in the man page for regexp. But the set that I've shown you so far should suffice you for probably 90% of the regular expression searches that you would ever want to do. So what programs actually use regular expressions? Well, obviously grep uses regular expressions. The program sed, which we'll look at shortly, uses regular expressions. Awk, we're also going to have a look at awk. And even vi and the line-based editors ed and x also use regular expressions. There's even more programs, but they're less commonly used, so I won't mention them here. So the bottom line is, if you ever plan to use grep, sed, awk, and even to enhance your power in using your vi program, it would be a very good idea to learn the basics that I've just shown you of regular expressions.